So continuing on with our polynomial functions, we're going to take a look at some more functions today, more than just the power functions that we did yesterday. So polynomial, basically where we started yesterday, but with a whole bunch of stuff added on to the end. Quadratic and linear functions are the simplest forms of our polynomials, but we're going to look at things more like cubics and quartics and things of that nature. So we're going to take a look at these three functions. And for each of the cubic functions, we're going to sketch a graph and we're going to circle its x-intercepts. So graphing it out on your calculator, that's kind of what this guy looks like. Okay, and I can see this cubic graph looks like we have three different x-intercepts. So I'm just going to do a rough sketch of this on our paper, and I can see I'm going to have some sort of an x-intercept over here. X-intercept, I had two of them on this side. So I had something, basic sketch, that looked like this. Okay, here's one intercept, 2, and 3. Okay, another cubic graph that we have, so our second one. Now, notice, same kind of graph, only this time we have one x-intercept. Okay, so different idea, it just crossed the x-axis once, turns back down and goes up. So there's your x-intercept. Okay, if we look at our next one, okay, now notice what happens. I have two x-intercepts. It's just, I can see one, it kind of touches the x-axis and then it goes back up. Okay, so one's going to cross it, crossed at 0. It turned around, it touched the x-axis, and then it continued on. So here's an x-intercept, here's an x-intercept. Okay, so we can see you can have a whole bunch of different answers. You could have 1, you could have 2, you could have 3, can't have 0 roots. Okay, just as with parabolas, there exists a tie between a cubic factor and its x-intercepts. Meaning, if I have my largest exponent is 3, that's the largest number of x-intercepts that you could have. Okay, so now we're going to consider this next one. Consider the cubic equation who's given. And algebraically this time, we're going to determine the zeros. Okay, so if we have to do this algebraically, it's basically saying to us we have to factor. So the first thing I'm noticing is that each of these terms have a common value of x, and I'm going to pull out that x. Okay, and so now we're going to factor that inside. So I need something that's going to multiply to be negative 12 and add to be negative 1, and that's going to get us x minus 4 and x plus 3. Okay, so if I'm going to find the zeros, I'm going to set each of these factors equal to 0. So one of our factors we can find is x equaling 0. Or another factor we could find if I set that equal to 0 and solve is going to be x equaling 4. Or another factor that we can set equal to 0 and solve is going to be negative 3. So if we were to go over here and plot this on the axis, first thing I would do is plot out my zeros, so I know I have an intercept of 0, I have an intercept of negative 3, and I have an intercept of positive 4. Oops, that's 3. Hold on. There's 4. Okay, and knowing that that first term, that a value in front of that cubic term is positive, that's positive, I know the direction of my graph, so I know it's got to go up, and then it's going to come back down, and then it's got to turn back around. And so I can tell you that at least with looking at my x-intercepts, that's going to be the basic idea of my graph. Okay, so now we have for number 3, the largest root falls between what two consecutive integers? Well, for now what we could do with this, you could try and factor by grouping, that's an option. You could also graph it. Okay, so if we were to graph this out, so we have x cubed minus 9x squared plus 12x plus 22. And I'm trying to find where it's crossing on the x-axis and between what two consecutive integers, my largest one. So I can see here's 1, 2, 3, 4. Between 3 and 4, there's a 0. 5, 6, 7. Between 6 and 7, it looks like there's another 0. So for my largest one, I would have to tell you it's going to fall in between 6 and 7. So now we have what's considered a quartic function, an x to the fourth function. They're asking us to algebraically determine the x-intercepts of this. Okay, so just like we did before, we're going to have to factor this. I know we've never factored a quartic, but it works just like if I said to you, think of this as being x squared minus 5x plus 4. It's going to work the same way, okay? So what I would have is I'd have to have two x's in the front and x times x equals x squared. Okay, so a little different here. I have to think to myself, x squared times x squared is going to get you x to the fourth. Okay, so just like we'd say over here, I need something that multiplies to be 4 and adds to be negative 5. Well, now it's the same idea. Something that multiplies to be 4 and adds to be negative 5. How about 4 and 1? 4 has to be negative, and the 1 also has to be negative. So we've just factored that. Okay, but now we have the difference of two perfect squares. So I can now factor this even more into x minus 2 and x plus 2. This guy over here, how about x minus 1 and x plus 1? So look at all of the zeros that we have. So I'm going to have either positive 2 or a negative 2 or a positive 1 or a negative 1. Okay, so we can sketch this on the graph. So I have negative 2, negative 1, positive 2, positive 1. And thinking back to our power functions, again, this is positive. So I know it's going to open up and it's going to function like a parabola where it's got to go something like this. So I know this has to point up. I know this has to point up. So then I have to think, well, it's going to come down, back up, come back down, come back up. Something like that. That would be some sort of our graph. Okay. And if we wanted to get real technical, we could find the y-intercept of this graph. We could make x0, plug it in, and I could find my y-intercept here would be at 4. So I could even label this if I wanted to and tell you that that would be located at 4. It's not really drawn to scale, but we get the idea. Okay, and then lastly, we have a quartic. Okay, another quartic equation, so x to the fourth. And we're going to sketch a graph of the quartic below, and we're going to label the x-intercepts. Now, we can't do the same factoring like we did up above. We have too many other terms. So we're just going to grab our calculator. We're going to take a look at what that looks like in our calculator. And so we've graphed it out, and I have all of the zeros found. So we need to sketch a graph of the quartic on the axes and label the x-intercepts. Okay, so we're going to just kind of do a rough sketch on our graph. And we know we had a 0 at negative 7, 0. We know we had a 0 at negative 2, 0. And we had a 0 at 1. And we had a 0 at 5. And again, this is positive, so I know it's opening up. So I know my graph has to open up this way and this way, and just like we did before. So it's got to come back down, come back up, come back down, come back up. And again, if we wanted to find the intercept, I could make x0 and solve, and I can say that this intercept has to be 70. Okay, so now thinking about what we did up in number 4, it's saying we want to write this in its factored form. Well, let's go back up to 4. So notice what happened. So all of these zeros that I have here, so I have 2 that came from this factor. I have negative 2 that came from this factor. Okay. And same thing with the 1s. They each came from these factors above. Okay, and I always think to myself, when I have my zeros, I want to think almost flip the sign, because remember what this was. We had to take x minus 2 and set that equal to 0. So then in order to solve, that's how we're switching those signs. Okay, so let's try this here. So if I know I have a 0 as x equals negative 7, switch the sign, the factor had to be plus 7. If I have a 0 at negative 2, switch the sign, that has to be plus 2. We have a 0 at 1, switch the sign, that's got to be negative 1. And we have a 0 at 5, switch the sign, that's negative 5. Okay, so we're going to write that in factored form. So our factored form, we have, how about x plus 7 x plus 2, x minus 1, and x minus 5. So we've just factored it basically by using the graph, finding the zeros, and writing it in its factored form. Okay, so we'll do a little bit more work with this in class. Please bring any questions that you have to class, and I hope you guys have a great day.